We have solved for the response of a damped SDOF system when it is subjected to an external force. This scenario is known as the forced vibration of a damped system, and its dynamic response can be further categorized into transient and steady-state responses. We know how the structure would react, but how about the reaction force at the bottom of the dynamic system? To inspect this, we first need to mark the reaction force. Let's use method of section and cut through both damping and stiffness component. Under equilibrium, the reaction force in the supporting ground equals to the summation of damping force and the force of stiffness. As usual, we only focus on the steady-state response of the system, since it persists as long as the harmonic load is applied to the system. The first derivative of the displacement response with respect to time gives us the expression for velocity response. Then, by substitution, we obtain an expanded version of our equilibrium equation. After simplification, we find the trigonometric relationship between C omega F and K to ease our work. Pythagoras' theorem is used, and we also introduce a variable called R. Lastly, we simplify the equation by applying compound angle formula. Recalling the steps we took to transform R into a term that consists on the damping ratio and frequency ratio, we obtain the final form of the equilibrium equation. Similar to motion transmissibility, we introduce the term force transmissibility. It is the ratio of base reaction force to the amplitude of the applied harmonic load. The effect of frequency ratio and damping ratio on the force transmissibility is the same as those for the motion transmissibility. In any case, it is desirable to have small transmissibility, best if it is smaller than 1. Transmissibility greater than 1 means the excitation is amplified once it reaches the other end of the system, and more effort may be required to mitigate the subsequent effects. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.